So part two. So next thing we got to talk about is the empirical rule, and this is the last thing for this section. So the empirical rule is also known as the 68, 95, 99.7 rule, and you'll see why those three numbers are super important. So if you have a distribution that is approximately bell-shaped, right? So it's a normal distribution. So low, high, low, and symmetrical. So remember we talked about how the mean will always go in the middle of a normal distribution. So we could put mu for the mean, right? So if it's normal distribution, then that means one standard deviation above and below, right? So if you added a standard deviation, so if you think about this as a number line, right? If you added a standard deviation, I guess that would be sigma because it's a population, and you subtracted a standard deviation, between this data is 68%. Between these two values is 68% of your data. If you go 2 standard deviations above, so if you add 2 of the standard deviations and subtract 2 of the standard deviations, this is going to contain 95% of your data. I'm sure you can tell what the next one is. If you're 3 standard deviations away, it's going to be 99.7% of your data. All right, so we're going to use these 3 numbers to figure out the rest of these problems. And like I said, this is the last example, but it just has like 15 parts. All right. A random sample of 100 students at a university had an approximately normal distribution. Normal distribution, all right. That's good. With a mean score of x bar equals 100 and the standard deviation of 16.1. Use the empirical rule to solve the following questions. So remember, the empirical rule is called the 68, 95, 99.7 rule. So determine the percentage of students who have IQ scores within 3 standard deviations of the mean. So the mean is 100. If we want 3 standard deviations away, we got to add 3 standard deviations. So basically, to get the top number, we need to get 100 plus 1 standard deviation, 2 standard deviations, 3 standard deviations. And when you add those up, you get 148.3. To get the bottom 3, right? So this is the top, and this is the bottom. So to get the bottom number, you just subtract 3 standard deviations. So 100 minus 16.1 minus 16.1 minus 16.1. And if you do that, you should get 51.7. All right, so we can see that we are 3 standard deviations between within the mean. So we actually didn't have to do any of that, right? Hopefully some of y'all probably already saw what the answer should be. Since we are 3 standard deviations from the mean, we're going to be 99.7%. That's going to contain 99.7%. That's the definition of the empirical rule, right? We actually didn't have to do any of this, but it was good practice. Yeah, it told us it was 3 standard deviations away. The empirical rule says 3 standard deviations away means 99% of the data, right? That's what we wrote. And that's it. But of course, it's not that easy. So let's look at part B. So same thing, but now let's determine the students who have an IQ score between 132.2 and 167.8. All right, so normal distribution. Number in the middle is 100. So we need to know how many standard deviations away these are, right? Because using the empirical rule, we only know it. We can only use the empirical rule if we know how many standard deviations away your data values are from the mean. So let's just figure it out. So let's look at the first number, right? 132.2. Is that one standard deviation above? So if we add one standard deviation to 100, right, we should get 116.1. Is that what we wanted? Nope. So let's add another standard deviation. If we add another standard deviation, we get 132.2. Is that what we wanted? Yeah. So we see that we are 2 standard deviations above. All right, now let's look at 67.8. So let's subtract a standard deviation, and what do we get? So we get 83.9. Is that what we wanted? No, because we wanted 67.8. So let's subtract another standard deviation. And we get 67.8. And that is what we wanted, right? So now this is 2 standard deviations below. So we are 2 above, we are 2 below, so that means we are within 2 standard deviations. And what do we say is within 2 standard deviations? If it's the 68, 95, 99.7 rule, it's 95%, right? 95% within 2 standard deviations. So in this case, the answer is 95%. All right. Part C. Determine the percentage who are above 116.1. So, like always, we have our 100 in the center, our mean in the center, right? So if we go 1 standard deviation above, remember we've already done this, and we saw that that actually was 116.1. So that is 1 standard deviation above. So some of y'all might think, oh, well, that means that that's going to be 1 standard deviation. 1 standard deviation was 68%, right? Done. But that's not correct, right? What was 68%? If we go back to our definition, what does it say? It says 68% is within 1 standard deviation from the mean. Right? Did we want it to be within? So this is 68%, right? This is 1 standard deviation within the mean. Is that what we wanted? No, we wanted it to be above 116. So this is the area that we wanted. We want to know what's this percentage. Well, let's think about this. If 68 is in the middle, what does the total percentage have to add up to be? 100%. So if 68 is inside, what percentage is outside? We can do 100% minus 68%, right? And we get 32%. So that means 32% is over on the left side and 32% is over on the right side, right? No, right? Hopefully you can see if we added 32, 68, and 32, you'll see that we actually end up with 132, not 100. And that's because 32 has to be the total number, right? So if 32% is separated equally between 2 different parts, how can we figure that one out? Well, we need to make sure to do 32 divided by the 2 parts to get 16. So this is the bottom 16%, and this is the top 16%. So what percentage of the IQ scores are above 116.8? We see it's 16%. And we did that using the empirical rule. All right, we're going to do a lot more problems like this that are a little trickier. So now let's look at what about the IQ scores above 51.7? So we got 100. Well, we know this is less than that, so let's subtract a standard deviation. When we subtract a standard deviation, we get 83.9. That's not what we're looking for. So let's subtract another standard deviation. We get 67.8. That's not what we're looking for. So let's subtract a third standard deviation. We get 51.7. So that's 3 standard deviations below. All right. Now again, you might think, oh, 3 standard deviations, that's going to be 99.7, right? That's what we said. But we're not trying to find within 3 standard deviations. We're trying to find above this number, right? So 3 standard deviations above and below are going to look like this. This is the 99.7%. But do we want just this area? No, we want all of the area, right? So we need this area as well, above the 3 standard deviations. And we can find this number, absolutely, but that's not really important to know for this problem. You don't really need to know what number specifically that is. Though we did figure it out in part A, right? We know that it's 148.3, but that's not really going to help us in this scenario. So just like how we did in this one, right? If we have a number inside, what percentage is going to be on the outside? So we know that 99.7 is inside. So then what percentage has to be outside? Well, total has to be 100%, right? So 100% minus 99.7% gives us 0.3%. But just like how when we had over here, right? When we subtracted, we got 32%. Remember, the total has to add up to 32. So then we got to split it in 2 sections, right? So 0.3% split up into 2 sections is going to be each of them having 0.15%. So this side has 0.15% and this side has 0.15%. So since we want above 51.7, that's going to be this area, right? Which is 99.7 and 0.15%. So 99.7 plus 0.15% gives us 99.85%. So that's our answer. Two more. So now determine the percentages of students who are between 83.9 and 148.3. All right. So let's go with the bottom one first. So 100 minus 16.1, and we get 83.9. Perfect. So this is 1 standard deviation below. Now let's figure out the second one. So if we add 1 standard deviation above, we know that's 116.1, which is not what we wanted. So let's add another standard deviation above, 132.2, not what we wanted. Let's add another one. And here we see we get 148.3. So this is 3 standard deviations above. Okay, so we got, so notice this is not going to be 68, because 68 is only within 1 standard deviation, right? That would be this percentage. This would be 68%, but we don't want this. We want all of it, right? It's also not going to be 99.7, because 99.7 would be 3 above and 3 below, right? That would be this whole section. We don't want that either. We want to be in between 1 below and 3 above. So we can kind of think about them individually. So let's just think about the first standard deviation below. So if we just think about 1 standard deviation apart, right? So just 1 standard deviation. If we cut, so we know that 1 standard deviation above and below is 68%, right? So then what percentage is it going to be below and what percentage is it going to be above the mean? Well, since it's split in half, right, that means this is going to be 34%, and the top is going to be 34%, right? If we split it in half, we get the bottom 34 and the top 34. And what do we want? We want one standard deviation below, so this is the percentage we want. All right, so now let's talk about the 3 standard deviations above. So we got 100, we got 3 standard deviations above, 3 standard deviations below. So we know within these two values is 99.7%. But we don't want above and below 3 standard deviations. We want just above 3 standard deviations. So if we cut it in half, right, if we divide by 2, we see that that's going to split up into 49.8 and 49.8. Or sorry, 8.5. Since we want the top 3%, or sorry, the top 3 standard deviations, this is the percentage we want, right? So if we kind of put it together, you can see this is 1 standard deviation below is 34%. 3 standard deviations above is 49.85%. So if you add those two together, right, the total percentage is 83.85%. Okay, that was a lot. If you need to pause this video, go back, re-look at everything that I did, feel free. We'll do one more example. So hopefully this is going to be a similar one just like that. So hopefully it'll be helpful. All right, so now we're between 67.8 and 116.1. So we get 100. We can look on the bottom side, right? 100 minus 16.1. We already know that's not the right answer, right? Because that was 83.9. So let's subtract another 16.1. And there we go. 2 standard deviations below. 67.8. 2 standard deviations below. Then we got 100 plus 16.1, which of course is 116.1. So this is 1 standard deviation above. So since they're not the same number, we got to split them in half, right? So again, if we look at, let's just look at the top 1 standard deviation. So 1 standard deviation we said was 68% total. So if we split that in half, that's 34 and 34. We're 1 standard deviation above, so this percentage is 34%, right? Above the mean, 1 standard deviation is 34%. Now we got 2 standard deviations below. So we know that if we are 2 standard deviations above and below, that's 95%, right? That's what the empirical rule says. But we only want half of that. So if you cut that in half, you see that you split it up in 47.5 and 47.5. Since we want below, this is the percentage we want, right? So 2 standard deviations below, if you see, right, this would be 47.5. So if we add these two together, we end up with 81.5%. All right, I know this can be pretty tricky, so definitely if you have any questions, let me know. Email me, text me, contact me any way you can. All right, have a great day.